Hello, yeah, we're back. Last time in our last session we did the binary addition. Now we'll proceed to do the subtraction. With the subtraction, this is binary arithmetic. And the reminder, this is a reminder, and I'll keep reminding until I'm done. Reminder, number of combinations. Let me not do that primitive stuff. Let's say number of combinations is given by 2 to the power of n, where n is the bits you are adding, the number of bits you are adding, bits added or subtracted. Now we're talking about subtraction, so this is the bits, number of bits, okay, that you use in the subtraction. So let's say now, so this is obviously, since we are going to use 2 bits, i.e. 2 bits is given by 2 to the power of 2, which is equal to 4 combinations. That is the count 0, decimal count 0, 1, 2, and 3. Now the binary, this is 0, 0, okay, 0, 0, 0, 1 for 1, 1, 0 for 2, and 1, 1 for 3. So we are subtracting only 2 bits. So our answers are obviously, when you subtract nothing from nothing, you've got nothing left. There we would say, I'll come back to that. Let me do the easy ones first. 1 minus 0 is obviously 1, and 1 minus 1 is obviously 0. Now if we look at an example like 0 minus 1, let's take an existing number 1, 0 minus 1, but I'm only worried about 0 minus 1. Okay, I'm worried about that part there. What do? We say we cannot do that, so we go to the next column, to the higher order column, and we borrow from there. What do we borrow? If these were units, these are 2's, so I'm actually borrowing a 2, okay, but the 2 in binary is 1, 0. So yes, it looks like I'm borrowing a 1 because I'm placing a 1 there, but no, the number is read together. Remember, if we said 87 minus 9, what did we do? We said this can't do that, so we come and borrow there. We borrow a 10 because it makes the 70 after I take away the 1. We come and say we borrowed 1. We say we borrow 1 from the thing. We borrow one set of 10 because this was what? This was 10 to the 0, and this was 10 to the 1. So anything that you take from this point is obviously got the what? The weight or value of 10 to the power of 1. That's why we come now and say 17. We don't say 8. If we borrowed 1, we're going to say 1 plus 7 is going to be 8, and you still won't be able to do that. But because we took this one set of what? Of the base was borrowed from the what? From the next column. So this was 10s. We borrowed one set there. One set of 10. That's why we come and say we have got 17. Now here's 17 minus what? Minus 9. And then we say our answer there is 8. Then we come and say, because we took away that one set we borrowed, we say we've got 7 left there. Okay, I think this is what we've always been doing with maths, and people know this. So all you have to do is assimilate that to the what? To the binary situation, and you would know that when we borrow a set of the base, in the same way that when we're doing the addition, when we're carrying a set of the base. Also in binary, when we borrow a set of the base. So now when you subtract, sorry, we borrow sets of bases. So this here, when I borrowed there, I borrowed a set of 2, and then now my answer is going to be 2 minus 1, which is going to be 1. So our answer is actually 1, but because we borrowed 1 what? one set of the base. We saw with 10 we borrowed a set of 10. With base 2 we borrow a set of what? We say 1, but then we say 2 because we borrowed a set of what? Of 2's. Okay, so we borrow a set of the base. Now we'll come and do some calculations here and say, okay, let's have a situation where we say 1 0 1 0 1 0 0. We say that. We say subtract 1 1 1 1. We say okay, it's all in base 2, so we say all right. Now this cannot subtract that. What do we do? All right, I don't want to do this. Let me first I want to, okay, what I want to do is I want to make it simple. I want it to build in. I want to build onto what we're doing here. I'm gonna delete this one. Instead, put a 0 here. I want an example that will highlight something that I want to show you. I've got 3 zeros here, a 1, 2 zeros there, a 1, and a 0 there. Okay, and a 1 there. What am I gonna do? I'm gonna try to subtract 1. I'm gonna subtract 1 1. I need to align my columns properly. 1 1 1. Let me say 0 0 1 1 0 1 1. Something I want to, this example here, it's all in base 2. This example here will show us something very important. Now this part is straightforward. 1 minus 1 is 0. Our rule says 1 minus 1 is 0. That's easy. Okay, now we have a situation where we're trying to do this. This is exactly what we did here. We're trying to do this, and this can't take away 1, so we come and borrow here. When you borrow here, obviously we remain with nothing because we've borrowed here a what? A set. These are 2's. Let's remember, these are 2's, these are 1's, these are 4's. So what's happened now is that we've borrowed one set of 4's. We've borrowed one set of 4's into the 2's column. So it's one set of 4's, but when it comes to 2, it's 2 sets of what? It's 2 sets of 2's. So this 1 actually means 2 sets of 2's. So we borrowed one set of 2's. 2 2's is going to be what? It's going to be, this is one set of a 4, but that was 2 2's. We are borrowing to the immediate side there. So it's like we borrowed just 2. Why? Because it's going to be 2 2's. So we just come and say 2 here. It's not 1, it's 2 here. If it was 1, you're just going to say 1 2 and say minus, but we borrowed. What I want to highlight, what I want to be very clear about here is that when we borrow a set. So because 2 times 2, so we borrowed 2. So I could write a 2 there, because 2 times 2 is 2. But because 1 0 already means 2, that I will say 2, and I'll say this is 2 on the 2's. 2 2's is a 4, which is exactly what we took. We took a 4. So this is 2 minus 1, it's a 1. Okay, so now when we now come and when we now try and do this subtraction here, it's easy because 0 minus 0, 0 minus 0 is already a what? A 0. I had to sort of mumble and whatever that was. Trying to explain this is a little bit difficult to I want to try to make it as clear as possible. Now we come here, we've got a problem here. Here it was easy, there was a 1 immediately there. Here I made it on purpose that we have a 1 so far away, and we need to borrow here. What do? We borrow there. But when we borrow here, we are borrowing what? We are borrowing to the immediate line. We borrow one set of the base, but only to the next, to the immediate right. So this here would have been us borrowing a set there. So that we've borrowed a set of 2. Whatever this is 8, this is 16s, and this is 32s. And you'll appreciate that 32 is 2 2. So actually borrowing 2 is what it's now the base 2. So now is 2 16s, which is 32. We took away from there, so obviously it makes sense. So when you've got 2 now here, we can come and borrow from that 2 and remain with 1. When I borrow from that 2 and remain with 1, it's because I'm borrowing to the next line here. I'm borrowing a 16, which is 2 8s. So this is 2 8s. So I've actually borrowed what? A 2. So 2 minus 1 now will then give us a 1. I hope that is not confusing matters. I hope this is making life easy. 1 0 is actually 2. I borrowed a set of 2 here. That's why I'm saying 2 16s. But I'm writing the 2 in binary because this is binary. So this is 2 8s. So that is 16. This is where I borrowed from. I borrowed a 16. And obviously that is true. Now this is 2 minus 1. And that is going to be 1. Okay. Now if you come there and say, okay, 16 minus 8 is 8. So this is an 8. We took away an 8 and we took it from 2 8, which is a 16, which is the what you borrowed from there. We didn't have anything initially there, but we had to come and take. So this was 2 sets. So what I'm saying is we're borrowing 2, not 1. So we are borrowing the base. So this is our base. 2 times that gives us 16. Of course, we took a 16. That 2 minus 1 gives us a 1. I don't know. I'm trying to be as verbose as possible. I'm trying to be as tautological as possible. I'm trying to repeat myself as many times as I can, so that probably I can wrap it in. Now, after we took away 1 from there, 1 set from there, we're left with 1. 1 minus 1 is therefore 0. Now, if you come and look at what we have now is, we took away from 32 there, so there was nothing left. So what is then the 0 minus 0 minus 0 will then give us what? 0. Now this is a similar situation, but we are going all that way. What happens is that what we are going to have to borrow from there, because there's nothing else to borrow from here. So we're going to borrow from there, and this is 64s. This is 128. This is 256s. This is what? 512s. It's increasing by a factor of 2. Ne? This is base 2, everything. In base 10, everything increases by a factor of 10. In base 2, everything increases by a factor of 2. So now, we borrow there. Obviously, we can only borrow to the next line, which is our what? Our 256. So 256, because I borrow a base, I borrowed 2. So 250, I move from 0 to 2. So I borrowed 2, not 1. So I borrowed the base. So 256 is now I can say, I can borrow from this 2 and remain with 1. And then I borrow next, because 156 is 2 128. So again, I borrowed 2 a base. So I borrowed the set 2 128 is 256. I took a 256 this side, so I borrowed 2 of them. So this is 2 minus 1. But I'm not there, I'm here. So I must borrow again from there, and I borrow 1 set, and that 1 set is actually what? 1 set of 2. That's why we say 2 now. 2 164s is 128. So this is 2. I borrowed a base. I borrowed 2 of them. So I borrowed a 2. So 2 times 64 is 128. So these 2 now can then, why am I doing that? I'm not getting rid of it. I'm using it. 2 minus 1 now gives us a 1. I don't know. This is me trying to make it as clear as possible. I hope it works. Now, we borrowed from that, so we took away from the 2. We're left with a 1. 1 minus 1 is a 0. Now, this 1 has got nothing here taken from it. So there, we already took away that 512 and gave it what? And gave it as 2 sets of 256s there. So we've got nothing left there. Right? So this is basically a useless spot now. So our answer is therefore what? Our answer is therefore that there. You could be asked to then convert this to what? To remember, this also meant 2 to the power of 0. This meant 2 to the power of 1. This meant 2 to the power of 2. 8 is 2 to the power of 3. 16 is 2 to the power of 4. 32 is 2 to the power of what is happening? How did you call the way there? 2 to the power of 4. And then this is 2 to the power of 5. This is 2 to the power of 6. This is 2 to the power of 7. This is 2 to the power of 8. This is 2 to the power of 9. Now, so let's suppose you were asked to convert your final answer back to what? Back to decimal. What you then do is that you then say 1 times 2 to the power of 8, or 1 times 256, 1 times 2 to the power of 8, which is equal to 256, plus 1 times 2 to the power of 6, 1 times 2 to the power of 6, and that will be 64, plus 1 times 2 to the power of 3, which is equal to 8, plus 1 times 2 to the power of 1, which is equal to 2. And we then add all those. This is 6, 4, that's 10. 10 plus 10 is 20. 8 and 2 is another 10. So this is 20. I carry 2 sets of 10. I'm the tens now. 5 plus 1 is 5 plus 2 is 7 plus 6 is what? Is 13. So I write 3. I carry 1 set. I'm carrying 1 set of what? Of 10. 10 tens. We're in the tens column here. It's hundreds, so I'm in the hundreds column. 1 plus 2 is equal to, so our answer there would have been, if you had been asked to give that answer in decimal or denary or base 10, your answer would then be 330. I'll deal with another example where probably you are asked to what you could be asked, just like in the previous scenario. You could be asked different bases. Maybe they could say a to the power of a comma e to the power of to base 16. They say subtract 7 comma 2 to base 8. Yes, you could do a times, you could say a times 16 to the power of 0, but a is equal to, remember a is 10, so instead of a, 10 plus e times 16 to the power minus 1, but remember again, e is what? E is 14, so we put the value to the power minus 1. I didn't put the minus 1, so this here is what? Obviously 10, and then subtract. This is now whatever you're going to get here is going to be what? Whatever you get here is going to be base 10, a base 10 answer. Subtract 7 times 8 to the power of 0 plus 2 times 8 to the power of what? Minus 1. And this here would also be us getting what? Base 10. And then what do? You then convert this to base 2. If they say do this in what? Do in binary, or compute in binary. Okay. Now, this then you have to convert to base 2. How? You divide onto the whole number part by the base 2, and you what? You multiply on the what? On the comma part by base 2. I'm not going to do that. I'll leave the students to do it this time. So this there also you need to convert to base 2. Same way, the whole number part, the whole number decimal part, you divide by 2, take the remainders up, and the comma side you what? But you could have also been allowed to do it in what? With the shortcut method, in which case you just say your a is base 16, so your a is split into bits of 4, or into 4 bits rather, and then you say your a is 10 1 0 1 0. We're doing 8 4 2 1, and then there e is 14 1 1 1 0. This is 8 4 and 2, no 1. So this here would be comma, and then this will be base 2. That would have been coming from base 16. And the 7 comma 8, you could have what? Could have said 7. This is going to be, the 7 is 3 bits, and obviously the 2 would also have to be in 3. Oh, what am I doing? The 2 would have to be also 3 bits, and then this would be 1 1 1 comma 2 is 0 1 0. Base 2. We all know after the comma, the zeros after the number are useless. After the comma, zeros after the number. If we had zeros before the whole number, then we know those zeros are what? Are also useless, redundant, in other words. So we would say we're subtracting that minus that. This minus that is equal to that, is equal to that minus that. So then say align your digits 1 1 1. Then this is base 2 minus 0 1 base 2. You can just balance up the digits because you lose nothing. It actually makes your life much easier. Align the commas again. 1 1 1. I'm aligning the columns also. So when you do that, 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. And then 1 minus 0 is 1. And 0 minus 1, I have to come and borrow. When I borrow, I'm left with nothing. So I borrow one set, and I've got 2. 2 minus 1 is 1. 1 0 is 2. 2 minus 1 is 1. Now I need to borrow from there. And that way I borrow to the immediate line. I borrowed a base, that is 2. Now I've got 2 to borrow from, and I'm left with 1. And then I borrow a what? A 2 there. 2 minus 1 is 1. 1 minus 1 is 0, and obviously that is also 0. So our answer then is that. We could be asked to change this to what? Change this to exponent for base 2 here. The base is 2. The exponent is 1 in this case. The exponent is 0 in this case. The exponent is minus 1 in this case. The exponent is minus 2 in this case. The exponent is minus 3 in this case. These are the exponents for base 2. Ne? For exponents for 2, for base 2. Alright, so now our answer, if we were asked to change it to what? If we were asked to convert this to a decimal, we would say 1 times 2 to the power of 1 plus 1 times 2 to the minus 1 plus 1 times 2 to the minus 3. Now someone would say, really, why do we bother saying that? Because really, honestly, 1 times anything will give us anything, just like we don't do 0 times anything. I really, at some point, I stopped halfway when I said I felt stupid to do. I said I felt stupid, then I didn't continue. I feel stupid really to be doing 1 times. It's actually much. Okay, let's not say there's anything wrong with it. There isn't anything wrong with it. You could do it, but also there's no harm if you just said 2 to the power of 1 plus everywhere where there's a 1, 2 to the power of what? We didn't do to the power of 0, did we? We skipped this one. We didn't do this one. Alright, so probably I would have to squeeze it in and say we missed a 2 to the power of 0 there. So what I'll do is probably just come and clean this one up and say I had that 1 is, oh, I think I was confused by the power here. I saw this one. So this is 1 times 2 to the power of 1 for this one. That one there is plus 1 times, let's create some space here, 1 times 2 to the 0 for this part. That one there is minus 1 plus 1. That one there is minus 1, and we have minus 3, so we had skipped this 2 to the power of 0 part there. Okay, I think I was messed up by that 0 there. So then I was saying there, is there really a need to do the 1 times? So as you can see, also in terms of space, it's not really friendly. So probably it would have been a little bit cleverer to just say 2 to the power of 1 plus 2 to the power of 0 plus 2 to the minus 1 plus 2 to the minus 3. It's the same thing. Okay, then you'd have your answer as what? This here is obviously 2, no 3. This is 2 and 1. 2 and 1, that is 3. Okay, that one there is what? That one there is plus half plus an 8, and 8 is 0.125, and then probably you'd fancy giving your answer there as 3,625. If we had been asked what to give our final answer in what, in decimal, then you'd have to remember that to get back from binary to decimal, to get back to decimal from any other base, you have to use the what, the weight, the best exponent system. All right, so I don't know, I think I don't have to make it any more confusing. I think that was good enough. If we understood here, I think we are covered with the what, with the binary I think it's up to the students now to do more examples. If they encounter problems, then probably I'm a contact away. Let's say cheerio. I enjoyed that. I hope you did too. Let's meet again when we're doing the binary multiplication. Thank you. Bye.